Okay, let's learn about a new kind of force. Let's talk about friction. Now to begin, I want you to try out a little demonstration with me. All you need is your hands and a flat surface, like a tabletop or a wall. I'm going to do it on this wall right here. So I want you to take your hand and lightly touch the wall or touch your desktop or tabletop and just slide your hand back and forth on that surface. Now you might feel a little bit of friction, a little bit of resistance between your hand and the surface, but not much. Now I want you to push hard on that surface. And when you do that, try again to slide your hand around. It's much harder to move your hand this time. You can feel that there's a lot more friction. So what's this telling us? This is telling us that the friction force between two objects is proportional to the normal force between them. The harder those two objects are pushing on one another, big normal force, the more difficult it is for them to move, the stickier they are with respect to one another. So we can say that the friction force is proportional to the normal force. Now mathematically, we use the symbol lowercase f for friction. And we write this constant of proportionality with a Greek letter. So we're adding to our Greek vocabulary. That Greek letter is called mu. It looks like a letter U, except it has kind of tail on the front. So that's our constant of proportionality. And we multiply by n, the normal force. Notice this is just magnitudes. That's the magnitude of the friction force and the magnitude of the normal force. If you think about the directions, the friction force is parallel to your surface, so parallel to your wall or desktop, where the normal force is perpendicular to the surface. Remember, that's what the word normal means. It means perpendicular. So, in fact, the vectors F and N are in perpendicular directions. Another thing about the direction of the friction force is that the friction force always opposes the direction of motion or the intended direction of motion. So let me write that down. The friction force opposes the direction of motion, or it opposes the velocity, or the intended motion. So there's kind of two possibilities in this statement. One possibility is that you are moving, and another possibility is that you're trying to move, but you can't because it's too sticky, there's too much friction. And we call those two possibilities the kinetic situation and the static situation. So kinetic friction happens when two objects are moving relative to one another. My hand is sliding on the wall. Static friction occurs when two objects are stuck together. You're trying to move, but it's too sticky, too much friction. Okay, kinetic. Objects are sliding against one another. Static. Objects are stuck. And we indicate that, those two scenarios, with a little subscript for our coefficient of friction. We have mu k for kinetic friction, and mu s for static. So what does this thing mu equal? What's its value? Well, it depends on the materials and depends on the situation. So the coefficient of friction is a number that you look up. People measure, engineers and physicists measure the values of these things for different materials. For example, if you have, say, a rubber trash can on concrete ground, there's a lot of friction. If you've ever tried to move a heavy trash can on the ground, there's a lot of friction there. So this may be a relatively large value. On the other hand, if you have, say, steel against ice, like an ice skate, there's very little friction, so that coefficient would be small. So there's a table in your textbook that gives you values for these things. And because this is a coefficient, it doesn't have any units. You can tell from this equation, F has units of newtons, normal force has units of newtons, so mu must be dimensionless or unitless. So mu is a measured quantity with no units. And generally, for most situations, the coefficient of static friction for a given set of materials is greater than the coefficient of kinetic friction. You can think about this like if you've ever moved furniture around. So you're trying to push a heavy couch or a bed or a dresser or something. You might notice that when you first start pushing that furniture, it's really hard to get it going. It just kind of sticks to the floor. But after you push for a while, it unsticks and you suddenly move forward, and it's a lot easier to push once it's moving. That's because to get it moving, you had to overcome static friction that has a larger value than kinetic friction that takes over once the object's in motion.